Hello, everyone, and welcome. My name is Rula Deeb. I'm a senior principal at Geosyntec Consultants in Oakland, California, and the coordinator of the webinar series on behalf of CERTUP and ESTCP. I have the pleasure of facilitating today's event. This webinar focuses on DoD-funded research efforts to increase energy resilience through microgrids. First, Mr. David Pinney from the National Rural Electric Cooperative Association will discuss the inclusion of private utilities in the microgrid planning framework to improve widespread cost-effective microgrid deployments. Second, Dr. Nathan Johnson from the Arizona State University and Mr. Chuck Kernick from the National Renewable Energy Lab will talk about the development of energy resilience training to standardize understanding and promote the use of microgrids at DoD installations. Each of the two presentations will be followed by a brief Q&A session, and depending on how much time we have left, we will conclude the webinar with a longer and broader Q&A session. The next two slides provide instructions on optimizing your webinar experience. If you have not done so already, please download Zoom at the link shown here and provide it to you in your registration confirmation email. If you cannot download Zoom, you can still view the slides using a compatible internet browser such as Firefox, IE, or Edge, and by creating a free Zoom account. If your screen freezes, try keying in Control and F5 to perform a hard refresh of your screen. And in case of continued difficulties, download a PDF of the slides from the webinar webpage and call into the conference line in your registration confirmation email. Another option to view today's proceedings is to go to the CERTUP and ESTCP YouTube channel, and a link is included here. Keep in mind that today's broadcast will be listen only. You can submit questions by using the Q&A box on your screen. Don't wait until the Q&A period to submit your questions. We do ask that you get them in well in advance of the Q&A sessions. And when you submit your questions, we would appreciate it if you can add your organization name at the end so that we can identify you during the Q&A session. Please do not submit questions in the chat box. The chat box is reserved for comments related to technical difficulties. And with that, I would like to introduce Mr. Timothy Tetro, who is the ESTCP Program Manager for Installation Energy and Water. Before joining CERTUP and ESTCP, Tim worked at the National Renewable Energy Lab, where he focused his work on energy efficiency and renewable energy project development for the federal sector. Tim, please proceed.
Thank you, Rula, and welcome everybody to today's CERTUP ESTCP webinar. Like Rula said, I'm just going to be providing a quick overview of the programs, and then we'll get back to the main content. So CERTUP and ESTCP are the Department of Defense's investments in environment and installation energy science and technology, and the programs report to the Deputy Assistant Secretary of Defense for Energy Resilience and Optimization, headquartered at the Pentagon. CERTUP is the Strategic Environmental Research and Development Program established by Congress as a partnership between the DoD, the Department of Energy, and the EPA. CERTUP addresses high-priority environmental science and technology opportunities that focus on the top priority DoD requirements. CERTUP funds both fundamental research as well as advanced technology development that ultimately impact real-world environmental management. ESTCP is the Environmental Security Technology Certification Program in which we demonstrate and validate innovative environmental and installation energy technologies. These investments capitalize on past investments under CERTUP or other research programs and are designed to transition technologies out of the lab and into the field. Especially important in all ESTCP demonstrations is the ultimate transition to implementation and regulatory acceptance. Advances in science and technology provide the DoD with the tools needed to effectively manage and restore its assets to protect troops, their families, the public, and the environment. CERTUP and ESTCP investments improve installation energy resilience, environmental cleanup, UXO remediation, resource conservation, and the sustainment and maintenance of defense assets. Startup and ESTCP fund monitor and actively guide relevant and applied research, development, testing, and evaluation projects for the DoD's top environmental installation energy challenges. Our programs currently fund over 600 active projects. To maximize research impact, CERDIP and ESTCP collaborate with a variety of top talent across sectors. In 2023, we funded projects with 77 academic institutions, 91 federal performers, and 52 industry partners. Our innovation and technology development informed DoD policy to ultimately improve environmental and energy management. Our webinar series highlights outstanding projects across our main focus areas, with the next EW, Installation Energy and Water webinar scheduled for later this month. And registration is now open for webinars throughout the end of the year. Here you can see a list of the upcoming webinars for the next several months. You can find additional information about upcoming webinars at this link, and all past webinars are archived and can be accessed at that website. I'd like to remind you that a copy of the presentation of today's session can be downloaded from our webinar page, and we would appreciate it if you can take a few moments at the end of the presentation to complete a survey that will pop up on your screen at the end of the presentation. At this point, I'd like to hand it back to Rula to introduce the speakers for today's presentation, and thank you for joining us.
Thank you, Tim. It is now my pleasure to introduce today's first speaker, Mr. David Pinney, who is the Analytics Research Program Manager at the National Rural Electric Cooperative Association, or NRECA. At this organization, David coordinates software and analytics research efforts among the cooperatives and their partners in academia, industry, and the government. His current research projects include cost-benefit analysis of distributed energy resources, distribution and transmission system simulation, sensor machine intelligence and modeling platforms, and decision models for resiliency investments. Prior to these efforts, he developed research software for NRECA, led consulting engagements for software and data mining company MicroStrategy, and built models, biological models, at the UCLA Institute for Pure and Applied Mathematics. He received a bachelor's degree in mathematics from Cornell University. David, we're delighted to have you. Please get us started.
Thank you for having me. So today I will talk about Microgrid Up, which is planning software we've developed to quickly identify high-impact microgrid deployments. Oh, there we go. So I'll talk about first the microgrid opportunities and challenges, then the software we developed to address those. I'll talk about installation plans that we developed for 4 military installations alongside their utility privatization partners, and wrap up with some conclusions and benefits. So the problem statement. The military and their installations obviously need electric power to operate at full strength. But unfortunately, the US electric grid has not been able to provide this power. We have suffered multi-day full system outages, and actually the single largest source of outage minutes for the military in the continental US has been bulk system outages. So microgrids could be a great option for resilient local power, but unfortunately they're very challenging and expensive to plan. A utility scale generation project, usually 10% is soft costs. For microgrids, 30% of the system cost ends up being soft costs, so planning and other activities like that. And also microgrids are an emerging technology, and there are not clear and well-tested methodologies for planning them, nor tools that are adapted to plan them well. And what has increasingly become an issue is a focus on decarbonization at DoD. And to achieve this, microgrids could be a great option to integrate renewable power locally and resiliently. So in this project, our goal was to basically build software to quickly and easily identify microgrids that are resilient and cost-effective for arbitrary military installations. So what we had to do, first we had to come up with a methodology, standardize assumptions and data requirements to actually perform this planning exercise. We then implemented software to generate the plans, which we have since released as open source software. And effectively, it's an optimization model, but it has to do optimization over a number of different things, including generation mix, distribution design, and control of the microgrids. We have field validated this tool and its results with 4 military installations, essentially completing full microgrid roadmaps for them, i.e. a set of microgrids that would cover all of their critical load, with also some options for alternative deployments. And we've compared our planning sort of effort and results to other microgrids that have been deployed at utilities and military installations, and found effectively that yes, our method is quite a bit faster. So before we talk about the tool, a little more motivation. The investment bank Lazard every year publishes a great summary of utility scale generation project costs that they have either financed or encountered. And all we've done in this chart is we've trended those costs. And essentially in the 2020s, what you see is it's about a 3-way tie between gas, wind, and photovoltaic generation. But the wild card is battery energy storage, which is rapidly dropping in price. So if you go out sort of to the 2030s, you essentially see that a hybrid renewable storage microgrid is cost competitive with gas units, which is a pretty good proxy for power from the grid. And so now is a great time to think about developing microgrid plans and getting comfortable with the technology, because in another 10 years, it's hard to predict the future, but this stuff could be not only resilient, but very affordable. So these are our demonstration partners for military installations. The great variety in size and mission and total consumption, from on the low side, Laughlin Air Force Base, about 8 megawatts of peak demand, all the way up to Fort Bliss with 60 megawatts, so small city, and a square footage that is about the size of the state of Delaware. So we had a really diverse set of missions and planning challenges on these systems. And I also want to point out that these are all utility privatization installations. That is, a local utility owns and operates the distribution infrastructure and some generation assets for the installation. And the reason why we're working with these utilities is because they have not just real high quality distribution planners on staff that know the system well, but they also have all the typical utility systems like SCADA, advanced metering, distribution automation, which provided a data set that allowed us to go really fast in developing these microgrid plans. So what does the software look like? I'm just going to show some pictures first and talk about high level what a plan in the software looks like. So we start bottom line up front with the financial overview, and we essentially show here's the number of microgrids that you would need to cover all of your critical load, and here is the capital cost and net present value of each of them to figure out, in the ballpark, what is the cost to get this resilience. But we also have to break it down into more detail, to keep the distribution engineers happy and assured that these are reliable and well-designed systems. So we, for each of these microgrids, generate an optimal set of generation. It's always a surprise between storage, fossil, renewable assets, exactly which units will perform best. And so each microgrid often has a different selection of generation. We also generate some control screens, including black start, inrush, current requirements, and fuel consumption requirements. Obviously, if you can't meet these, your microgrid will not operate effectively. We have a sort of full GIS interface in the tool because to find our candidate microgrids, the first thing we do is we segment the entire installation electrical infrastructure to group together pockets of critical load so we can draw tight microgrid boundaries and support only the critical assets and not the non-critical. Also, obviously, with talking with stakeholders, there's a lot of detail to mission and location. And so we found this very helpful for explaining, this is how the assets will be deployed. We also do some further control screens to look at how the microgrid leaves and joins the grid and how the switching will be operated, as well as generator dispatch. When we started the project, we wanted to do a very high fidelity control simulation, but I'll talk about that in a little bit. And finally, we generate some detailed resilience metrics. The microgrids we propose are constrained to only meet the minimum resilience requirements, which for these installations is typically between 7 and 14 days of islanded operation. But once you have these microgrids, you'll also be able to avoid a lot of other outages, either of the bulk system or inside the fence. And so by looking at historical outages, we can figure out which of these could be avoided with the microgrids that are proposed, and which is another nice benefit. So we have software folks on our team. So we, of course, do user stories. Our key user is a distribution engineer, either at a utility privatization utility or serving utility or inside the installation. And essentially, the goal is, they understand their requirements for resilience, and they want to quickly find microgrid options to present to stakeholders. Our secondary user is energy management staff on the installation. Maybe they're not as deep into the details about how the electric infrastructure is designed, but they need to be able to see the results, understand them, and also modify the assumptions quickly. So as things change, they can get an updated plan. And those are our key users we're targeting. The inputs, what we came up with, you see here on the left, kind of the key data types. We obviously need meter data to know what load we're supporting. We need the circuit model because that dictates where and how assets will interconnect. We need cost of power because the rates that are being paid for grid supply often dominate the economics of these systems. We need criticality data because we don't want to support non-critical load. If there's a golf course on the installation, we're probably going to load shed that. And we need the resilience requirements in detail, which are sort of historically, what are the threats to resilience and what are the goals for survivability. And what we found in working with these installations is there's kind of an ideal set of things and an acceptable set. So if you have very high resolution, high quality data, you can start to draw really tight, very local microgrids. But this is not always available. And so there's sort of an acceptable level of data that everyone we worked with had, and we believe is widely available. You can't draw the boundaries of the microgrids as tightly, but you can generate sort of circuit level and substation level designs. So, we take the inputs, we generate the outputs, and we have detailed generation options and distribution upgrades, relaying, et cetera. And, we price it all out to see what it'll cost. We have some papers on exactly how we're doing this, but the key is we start with this high quality utility data set, and then we go through a 3-stage sort of tiered optimization approach, where first we cut up the circuit for microgrid boundaries. We do hosting capacity to figure out, how much generation can you even add here in the case you want to overbuild. Then for each of those candidate microgrids, we generate the resource mix, i.e. the generators that would most cost effectively meet the resilience goals. And then we go into those control screens. And there's a feed forward process here because sometimes proposed microgrid will fail a control screen. So we go back and we adjust the resource mix, et cetera, et cetera. It would be great to do all of this as one single optimization problem. That's unfortunately beyond the state of the art. There are folks working on this, but we were able to get some good results with the staged process. And then finally, nice graphical output reporting. So let me show you an example of what the results would look like. Here, I'm going to use our synthetic test system, quote unquote, Lehigh Air Force Base. All the data is fake because we don't want to talk about real installations. We essentially put together a full fidelity data set that is not real, but is, similar to the kind of load levels of military installations. So the bottom line results, before we look at that, so here's the segmentation the system came up with. Effectively, there are 4 natural microgrid boundaries on the circuit, which roughly equally lump the load, microgrids 1 through 4. And then as a comparison case, we also looked in these results at a single central microgrid to support the entire installation. So in the results here down the left, I have each of the individual 4 smaller microgrids, the summary results for all 4 deployed together, and then the central microgrid. If we look directly at CapEx, we see the central microgrid is going to come in at roughly $4 million, which could be too much money. So the individual microgrids kind of hit more affordable price points between 500K and 2 million. And what we're seeing a lot is, folks can't build a microgrid for, say, 60 megawatts at Fort Bliss, but they can get started with the technology and pick off their most critical loads with these smaller, more tactical microgrids. We also calculate net present value. These are all positive due to the input parameters we chose. That is not typical. Microgrids are not money makers yet. We also, of course, summarize outage survived. They all meet the minimum 48-hour requirement, but with microgrids, you'll often find you'll design for 48 hours, but really, even with your worst case load and renewable resources, on average, you can survive longer. We, of course, calculate emissions reductions because that is a new goal emerging in DoD, and there's a lot more detail about what is actually in the microgrids and what they're supporting. And that was the summary I just gave. So I won't go through the exact parameters for all the 4 installations we planned for. Very diverse, incredibly diverse in terms of resilience threats and mission and size and scale. So what did we find at a high level? Because we can't talk specifics. So we developed these plans. Everyone was interested in 7 to 14 days of critical load survival. And the kind of sweet spot for analysis, we looked at installation level, substation level, and circuit or feeder level. Essentially, the feeder level results were all quite attractive. That was based on data constraints, but also based on price points that we were predicting. And for these installations, you need, between 1 and 33 microgrids to cover the full footprint. So costs were seen as acceptable. We were seeing, $500K to $1 million per feeder level microgrid. These were entirely fossil backed with a little bit of battery and renewable resource as well. Those were the cost optimal options. We did study renewable only microgrids. Long story short, extremely expensive now, but we expect that to change. There was a huge variability in cost. There are essentially 3 key factors: the rates you're paying to your bulk commodity power supplier, the renewable resource you have available, and then also the distribution of critical load. So if you're in the desert Southwest, you're paying high energy rates and all of your critical load is on one circuit, you probably should have a microgrid tomorrow. If you're in, I don't know, North Dakota, you have very low energy prices and your critical load is evenly spread, it's going to be very difficult for you to find an attractive microgrid to invest in. Distribution automation, we saw was a very powerful tool. So there's typically a mix of critical and non-critical loads in any kind of microgrid boundary you draw. You can either sort of overbuild the generation to support all the load, or you can disconnect loads that are not critical. The disconnects ultimately came in cheaper. And we also think it's a nice approach qualitatively, because if criticality ratings change for individual buildings, load control means you can just change the control scheme and don't have to, change any equipment. And after we got through all of this, we found two sort of sets of microgrids at two different installations to go into detailed modeling. And essentially the key was high criticality concentrations, and also high energy prices can also dictate affordability of microgrids. So a specific example with Fort Bliss, it's the size of Delaware. It's an extremely challenging planning case. We centered on a cluster of 4 different microgrids that the installation was excited to pursue further. It was a combination of truly criticality to their training missions. There were existing power quality issues already at these sites, and there was a very high cost of power due to the remoteness. So the serving utility, Rio Grande Electric Co-op, came up with a sort of innovative financing mechanism that is available to them, as they are a nonprofit. All our co-ops are not for profit. And so now they're looking further into the final equipment selection, cybersecurity, and hopefully moving to construction. So when we started this project, we thought, well, we'll do a perfect control simulation. And in this timeline, I'm showing the sort of the steps in planning and deploying a microgrid. And on the planning stage, we do generation mix, hosting capacity, criticality, clustering, that's all fine. And as I explained, we do a sort of control simulation screen, looking at basic order of operations for switching. We wanted to do a high quality analysis, but it turns out when you try to buy a microgrid, you have to go into an RFP, request for proposal, where your respondents will actually identify the equipment they are willing to sell you. And without knowing that equipment, you can't do that real, true high fidelity control simulation. And so as a mitigation, what we looked at is we took our fully modeled system, the circuit with all the additional microgrid components on that, and we exported it in a way that our partner for this test, Typhoon HIL, could consume. And they showed that they could run these high fidelity control simulations on that other side. So while we would have liked to solve the entire problem perfectly, this sort of keystone issue is tricky and something that honestly no one has a great solution for yet, short of some different contracting vehicle maybe, but I'm not aware of one. Planning time and performance data. So we looked at existing microgrids that were planned and deployed and the engineering analysis required. And then we looked at our efforts and the engineering analysis required, and roughly came in, it took out a significant portion of that time. And what this also made us think about is, well, we're putting together plans with, say, 33 different microgrids instead of one. And so it changed the way we thought about the tool. It's a design tool, of course, but what it allows is microgrid prospecting. You can look at hundreds of options and find something that really fits your needs and capabilities at the time. And I think going forward, we're going to do more of these kind of large scale studies. Technology transfer. So NRECA, the group I work for, national organization, supports over 900 rural electric utilities. 125 of them serve military installations. And so now we're looking for our next and our next and our next installation to help out here, because it's in line with our nonprofit goals. We're of course networked with DoD end users, as well as the energy service companies, which are, contract energy service providers to the military. And yeah, looking to essentially take this further and help more of these utilities and utilities in general, and military partners. So microgrids, they can meet resilience goals. Affordability is improving. We validated our idea that partnering with these UP, utility privatization utilities, could provide a really high quality data set quickly. We did see that this end-to-end planning process allows for identifying attractive microgrids, as we saw in how folks wanted to move towards the investment. And we are rebranding as a microgrid prospecting tool and hope to prospect many more microgrids. Key benefit is, this microgrid processing. We validated sort of, yes, it is quick. And if you're interested in the deep technical details, we have some peer-reviewed papers that, checked our reasoning. And if you're interested in more information or want to download the open source software, please go to microgridup.org. And these are some of our citations, essentially looking at what are the real resilience challenges in the military and what are the microgrid costs. So that's my presentation. If we have time here, are there any questions I can address?
Yes, thank you so much for a great presentation. And just a reminder to everyone, you can submit questions by using the Q&A box on your screen. David, we've received several questions. The first one is from the University of Michigan. What weather data do you consider to estimate capacity factors for solar and wind resources in your optimization?
Yeah, so we rely on climatic data from NOAA and NREL for, I believe, wind and irradiance. We essentially have to lay these over time series fashion with the demand to figure out the coincidence of renewable resources and load. This methodology is pretty common at this point. It's not a perfect forecast of the future, and we're thinking hard about how to put some error bars on this kind of analysis.
Great, thank you. And this is a follow-on question from the University of Michigan. What security constraints within microgrid line or generator outages are included in your resource mix planning?
Ooh, like bulk system security constraints or threats to just to the microgrid locally?
I think more broadly, if you can address security constraints, that would be great.
Security constraints. Mostly from security, we were looking at a data security question since we're at the planning stage. And we did not look at operational security of these systems. We relied a lot on our utility privatization partners because as system owners owning these distribution systems, they have put a lot of controls in place to make sure that they are secure and meeting the military's needs. So when we run the tool, we run it inside of this sort of already approved environment.
I think this is a great start. Thank you so much. This next question is from KitsWorks LLC. How important are peak demand reduction and energy use reduction and efficiency?
Ooh, hugely important. So natural gas units were always more attractive than diesel because you can use them for demand management. In effectively no cases, we found solar to line up well with the demand on these installations, but we did see cases where energy storage was essentially paid for a lot of its cost by shifting some of those renewable resources onto the peaks. These installations are, like most large consumers, they're paying very little for energy and a lot for demand. So it's a great cost saver in these systems. In fact, the primary way that these systems are helping to pay for themselves.
Wonderful. This next question is from the Air Force Civil Engineer Center. Have mobile microgrids been considered for disaster areas or for expeditionary installations?
Ooh, so we didn't look at mobile microgrids. We're hoping to look at this in the future in the context of vehicle electrification, because there's a demand for these vehicles and they're also an amazing energy storage resource. Expeditionary is a bit outside of our expertise, but we have been watching with great interest the tactical microgrid standards. Really, a lot of the difficulty in getting microgrids built is that they're always custom one-offs. And so being able to, snap things together like Legos, I think would really speed up the later stages in the deployment.
Great, thank you so much. This next question is from Paired Power. Were you able to quantify the additional value to multiple smaller microgrids compared to the central microgrid?
Yeah, so usually more microgrids, the more you have, the more you'll spend relative to central microgrids. It's just additional components as well as additional sort of planning and procurement headaches. But all of our installation partners were interested in the smaller multiples because the upfront costs, for Eglin Air Force Base, 40 megawatts, tens, hundreds of millions of dollars. And so folks right now seem to be interested in, let's build smaller microgrids at our most critical sites to cover them, and also to get our feet wet with the technology and understand how to deploy further.
Thank you so much. This next question is from Naval X. Is there a cost to installations to work with you?
We're still working that out. We will ultimately have to do that to cover our labor costs. We're not charging for access to the software itself. We're looking at some options right now to stand up this kind of repeatable consulting practice. But it's relatively low cost because there aren't a lot of planning labor hours involved. The kind of the nice to have additional time we spent in this project getting into interviews with mission owners. And we found, if you really want to drill down on criticality and figure out a real cost of an outage in dollars or other terms, you really have to sit down with a lot of folks to understand that.
Great, thank you.
As soon as we know
Go ahead.
as soon as we know the answer to what we can provide, we'll have it up on microgridup.org.
Thank you. This question is from Freelancer. The software tool link on microgridup.org says link coming soon on the website. When will that link be provided or be activated?
Ooh, that's embarrassing. As soon as I can talk to my webmaster. So I hope to have it up before Monday.
Wonderful. That's the best response ever. All right. Next question. Amaresco. What types of grid-tied value streams did you consider for renewable microgrids when assessing their economics?
Yeah, so the main was peak demand management. What we found in almost all these cases is folks are in contracts where they cannot export energy. We did also look at self-supply, avoided cost of grid supply. The reality is, though, energy costs in almost all cases were minuscule, and so that wasn't a real provider of value.
Thank you. This next question is from SNC Electric Co. Do you have any comments on UFC 3-550-04 resilient installation microgrid design on the scope of this project?
Unfortunately, I'm just the software guy, and my military specialist, I don't believe, could be on today. If you email me, I can get back to you on that.
Thank you, David. And just a reminder for our audience, the PDF of the slides is uploaded to the webinar webpage. We're going to drop a link to them in the chat box right now, and you can download the slides, and they contain all of our speakers' email addresses and phone numbers in the event of follow-up. All right, one last question before we move on to our next presentation, and any unanswered questions we'll get to towards the end as time allows. This is a question from the National Renewable Energy Lab. Can you provide more context on the source of your statement? 30% of microgrid costs are soft costs. Or can you elaborate, please?
Oh, yeah. So actually that's comes directly out of an NREL paper, which is listed in the slides under resources. Survey paper from roughly 2018. But we're definitely interested in how that number is changing.
Great. Well, thank you so much for a wonderful presentation and a very engaging Q&A. At this point, we're going to go ahead and transition to our next technical presentation that will be given by two presenters, Dr. Nate Johnson and Mr. Chuck Kernick. In ways of introduction, Dr. Johnson leads numerous efforts at ASU to accelerate the advancement of sustainable development goals through innovation in stakeholder value propositions, technology, business models, and policy. In this role, he builds public-private partnerships globally to develop energy decarbonization solutions leading to pilot demonstrations and scale. Specific to the DoD, Dr. Johnson leads or co-directs over 10 active projects supported by the Office of Naval Research and ESCCP, with a focus on translating research to on-base pilot demonstration and scale. And before joining ASU, Dr. Johnson spent 10 years in industry and academia, working in product development and business development with projects across 15 countries. He received bachelor's, master's, and doctoral degrees in mechanical engineering and a master's degree in international development from Iowa State University. And our second speaker, Mr. Kernick, is a senior engineer focusing on microgrids in the Energy Security and Resilience Center at DOE's National Renewable Energy Lab in Golden, Colorado. Chuck has been with NREL for nearly 15 years and leads their support services to the U.S. Navy and Marine Corps to enhance energy resilience. He has supported DOE's Weatherization Assistant Program for over 12 years and was the site operations manager of the DOE Solar Decathlon in both 2013 and 2015. And before joining NREL, he spent several years as a manufacturing engineer and field engineer, designing, installing, and maintaining remote geophysical data collection systems. He also spent 3 seasons at McMurdo Station in Antarctica as a research engineer. His degrees include a master's degree in mechanical engineering from Colorado State University. Nate, I'm going to turn it over to you to start us with this second and last presentation.
Perfect. Thanks, Rilla. Super happy to be with everyone today. And it's an excellent set of speakers, David, myself, and Chuck, because looking at, again, a new industry and growing industry of microgrids, massively and rapidly changing requirements and technologies, there's a lot that we don't know. And in addition to addressing that soft cost proportion, you need to have the right tools, the right knowledge, and the right skills. And so looking at those three things, David did an excellent job of talking a lot about the tools and then also touched lightly on the knowledge and skills. Where Chuck and I'll talk to you today is largely on the knowledge and skill side of things and lightly on the tools. So with today's presentation, you kind of get all three things that are driving at reducing those soft costs, and noting that you still have, 70% of the bill coming into the hard costs. You want to make sure that's actually spent on the right thing. Yeah. So that's another important consideration, is having the analysis tools, the knowledge to ask the right question, and the skills to get the job done. And so hopefully this set of presentations and the Q&A today provides everyone with the interaction to advance their needs. And then with the three entities working significantly with the DoD, other federal, commercial, and industrial customers, municipal, critical public services, we've been able to curate generalizable knowledge and capabilities to leverage our non-DoD work for benefit of the DoD as well. And so you'll see some of that coming today also through demonstrations. And then it helps us also just figure out not just which technology goes in, but how do you curate and broker the new business models, value propositions, and ownership models, so it's not just a sunk cost for the government, it actually helps reduce costs overall as well. So very happy to be speaking with you today, and we'll jump into some of the training aspects. So in addition to kind of the motivation needs, we'll talk about the MOS specialities and the GS occupation, some content types, and then Chuck and I'll tag team a little bit on some training examples. And at the end, we'll tell you about 6 trainings that are coming up within the next 3 to 4 months. And then we also create semi-tailored content and semi-tailored training where you can come to us, or we can come to you, or we can do a virtual session for some of your specific needs as well. And much like what David is kindly saying, is you can get access to the tool for free. This is a sponsored ESTCP project, kindly out of Tim's program. And so our intent is to train 600 people at minimum. And so we're very happy if you contact us and you would like some training, either existing ones, you want to come to those, or again, something that you want that's semi-tailored to your need. So a little bit about those objectives is, again, NDAA advancing and requiring everyone to have resilience. But then also another caveat to that is only 50% can come on taxpayer dollars. And so that's a pretty hard challenge to ascertain solutions to. And so across this industry, there's not standardized training, job specialities anywhere, civilian or defense sector. But it doesn't mean we can't get started, doesn't mean we shouldn't make progress, and doesn't mean we shouldn't learn. And so that's a job of Chuck, myself, and our colleagues at our partnering entities, Converge Strategies and Slipstream, which we'll kindly have in some of the notes at the end to recognize those individuals as well. So enhancing the understanding, facilitating collaboration, and then disseminating a standard design approach. That design approach that we're leveraging here has 7 steps getting down to actual construction. So after that, you'd also have, of course, the actual procurement of assets, installation, and more. For us, this is all the training that we would provide, and you could do this prior to actually procuring equipment. Sometimes those later stages for commissioning and deployment, we get pulled in to help support projects that are soon to be deployed that we weren't involved in the design of, and that's fine too. Right now, we're supporting about $300 million of IRA funding that's all focused on microgrids in urban and remote locations, using this process that we've curated over the last 7 years, working with a variety of partners. And so this gets more and more detailed, and we also have publications that are forthcoming and white papers to reference some of the data and inputs in this. So this generalized process, then we can layer on for branch-specific needs, for base-specific needs, for regional needs, what are not just the input needs, but then what are the paperwork needs? What are the unique requirements? UFC guidelines that was referenced by one of the guests. But then also, who are the exact decision makers? Even if you're working within NAVFAC, depending on which region you might be, you might have a different job code tied to making certain decisions. And all of this is realizing that as a profession and as an industry is that not everything goes well the first time. It might not even go perfectly the 7th time, the 10th time, or the 50th time. And it's part of a thing that we embody just in the principle of innovation generally is that we can't wait to do what's perfect and delay any success at all. Part of innovation is learning, it's exploring, and then also realizing the things that didn't work and what could be done better. It's any new and growing profession. Happened with solar, happened with wind, it's happening with microgrids. And so we're just very open and honest about that when we look at the standardized process to help people through this, to navigate and be aware of the blind spots, train and provide the tools and skills to relieve those, but then also provide an environment for peer learning, much like Converge Strategy does an excellent job in their MERC program, to permeate knowledge across, which was our second motivation of this work, to enhance skill sets and abilities through peer learning because it's a growing profession for us all. In doing a training needs assessment, and again, we already have about 500 hours of content, been doing training for the past 7 years, have over 3,000 people trained. But for every new group, and we've been training a number of installations, but taking this and scaling it and working with ESTCP to formalize it for the long term, engaging with uniformed and GS personnel, but then also contractors. I think it was about 150 people interviewed and surveyed, in addition to the 1,000 people that we trained this last year and getting surveys and follow-ups from that information. Categorize the knowledge and skills into 8 different areas of energy and then 5 different areas of cyber. And then we dive into very specific details of what you would need for each of these. Now, this is obviously far too small for you to go into, but you have the slides. If you want to go and take a look at it next, you can see on the left how we've mapped for each branch the job title, MOS or GS, against those 8 energy and 5 cyber requirements. Because part of our realization as well is that these individuals are getting asked to do the work, but it's not part of their job requirements. And so it's not just the training that we need to provide, the education, the skills, but it's also helping the DoD update their job requirements so people can get honored and rewarded for the work that they're doing. And that's also really important from an individual career path development perspective. You see some civilian job codes here as well. So some of those needs assessment results found kind of grouped into 2 major areas that we found people indicated that they lacked information on. Early stage gaps is just, what is a microgrid? And yeah, okay, I'm told that I need one, but what the heck good is it going to do? And that will lead to projects that are poorly scoped if you don't understand the basic vocabulary and concepts. Also, how that could change the financial structure of how you work with utility, local regulations, and more. And furthermore, to finance that, is it going to be through an ESPC? Is it a MILCON? Is it an ESTCP demonstration project? Is it part of your standard FSRM budget that you're incrementally adding to over the long term? And David hinted and highlighted some of those as well as these, now that you've got the right type of system design, do you even know how to fund it? And are you potentially limiting the scope of your goals and your ambitions based upon your assumption of certain funding streams may or may not be available? And so that's a really great opportunity where Chuck, myself, and our teams get involved, is to help people better understand the scope of the problem and also often expand the scope of the problem to realize what other levers and areas they can bring in to help design a better solution. Later stage gaps gets in, okay, I know I need a microgrid, it's about this size, but the design, implementation, and more. And that's where tools like Microgrid Up, and there's a variety of other tools for power flow or design and system sizing as well that both all of our organizations use for design, but then also real-time simulation operation would employ at this stage. And then a great curiosity or question is, sometimes installation or a unit or a command might have enough people to train to do that work. Sometimes they might work with a preferred partner. NREL has done an excellent job working with a number of installations in this way. And then sometimes they might actually contract out an entity to provide an ad hoc support system. And so that's another area that we see as needed. In augmenting the work we have in terms of career specialities, we have managers, designers, operators, and technicians. We also provide the knowledge and skills in 3 different levels: beginner, intermediate, and advanced. And the first 2 kind of speak for themselves, but to speak just briefly on the last one, is once you know how to use a tool a little bit, you have a project that you want to work on. That's more of working like almost more on a project consultancy basis for your specific need, for your specific installation. It's this set of buildings, here's the critical load, here's the utility rate structure, and then working hand in hand, or the individual might be doing the design themselves, but then we're providing third-party guidance to that. And so we've done a lot of the first 2, and then that advanced one is something we're getting into in the midterm part of our ESTCP project, as people are raising their hands and saying, okay, now I have this project, I want more specific design guidance on my exact unique need. And that's where we're setting up things such as like essentially office hours or open hours that you can work with us. I'm going to give a couple examples of how we deliver training, and then I'm going to kindly hand it over to Chuck to provide a bit more here. Noting, numbers in the hundreds and low thousands of people to be trained, and again, that's just within the federal and DoD sector. If you think, broadly and internationally, tens of thousands and hundreds of thousands, having self-paced content is a great way to meet scale. And so we have some beginner and intermediate content, lectures, quizzes, and readings, but then on the right is some computer-based simulations of, how you hook up things, what PPE are you wearing, and some basic stepping stones before you get to actual physical testing and implementation. We also have a variety of case studies given the installations that we've worked with. Some of these are like 1-page summaries, and then we utilize these in tabletop exercises that allow all stakeholders, regardless of their background, technical or non-technical, can engage in an active conversation about how their roles need to coordinate and share information to meet unique needs for their situation. This is an example for this presentation. This is a public example, so that's a fictitious base but has realistic characteristics with it on the left. And then we even developed a board game that's been really enjoyable to, kind of break up when, like how most trainings are done, is massive doses of PowerPoint presentations. And that's not how Chuck, I, and our colleagues like to work. And so we like to break it up with hands-on simulations and then competitive and cooperative games as well. When we think about design simulations, and so REOPT and system advisory model developed by NREL. We also use Zindian, or their preferred training partner, ETAP for power engineering, INCSys for real-time simulation, OPAL-RT for hardware in the loop simulation, and we also do a cyber warfare range for attack defense scenarios. And so these are just a couple of the tools that we have trained on. We have preferred partnerships to train on. And again, that coupling the tools with the knowledge and skills is really important to us. Hands-on is also extremely important to us. And it still sometimes surprises me where you can get certified in a profession without actually having touched any equipment. And so with us, with microgrids, both at ASU and at NREL, that's just a picture from ASU there on the left, is working with systems. And we have that right there is, I think it only goes up to 240 volts, but our system here goes up to 1,000 volts. And we have our certified safety manager on site, as well as take people through certification electric safety training to be able to use and work on systems. And one of the importance is not just how to wire the system, but microgrid includes a whole bunch of different assets and electrically connected, digitally communication connected. And, when you turn it on, when you turn the key, lights don't always come on. And so how do you think about approaching something that isn't just one asset, it's 5 to 10 assets, the balance of system, and, end to the end amount of communication, electrical connections. It's a really challenging thing to troubleshoot. So we actually have targeted training to become like master troubleshooting experts or master technicians, where we take and safely break or disable the system would be the better use of the term, disable the system, and then help people think about how do you confront a confounding situation that's not clear on what the problem is, with fishbone diagrams and more, and then again safely architect it and then to help them think through how they approach it. We also develop training programs for physical systems that are not at our facilities, and so that one on the right is a setup we did for Exwick at Port Hueneme, on utilization, commissioning new assets, but then also modifying their real-time controller to be utilized under a variety of different testing scenarios. And so with that, I'll kindly pause and I'll ask Chuck to come off mute, and he'll talk a little bit about some of the training that NREL has done.
Great. Thanks a lot, Nate. I appreciate the opportunity today to speak with the ESTCP program. So yeah, I'll talk a little bit about some trainings that we've done, kind of some lessons learned, and how we've reintegrated those back into the trainings. And so last September, we hosted a training from NAVFAC Southwest, Naval Facilities Engineering Command Southwest, at NREL. Last September in 2023. We had about 35 attendees, several from the NAVFAC Southwest region, so project managers and engineers from that region. We also had several installation energy managers from that region, hosted some NAVFAC headquarters staff, as well as the San Diego Gas and Electric federal representative, the local utility that serves many of the installations in the Navy Southwest region. And this was to that date, that had been the most comprehensive in-person session that we'd had. And we had 3 days, and we had a feedback session at the end of that where we discussed what worked and what didn't. And so on these next slides, I'll give you some examples of that feedback that we received and what we've been doing to address it. Slide 62, please. So here's just the agenda that we had. It was about 6 to 8 hours each day, and it included tours of a few NREL facilities and some demonstrations of some different tools that we have and some scenarios. Slide 63, please. And so here, on day one, we started out with some basic information. And so some of that was around basics of electricity and introduction to resilience and microgrids. And the feedback we received was that was too basic for some, and it was just right for others. So some of the more experienced folks at NAVFAC and at the installations, it was a little too basic. It was really great for some of the NAVFAC headquarters staff. So that was one thing that we learned. And what we decided to do from there was we started to implement the beginner, intermediate, and advanced trainings for the DoD teams. And we've got a few of those on deck right now, and you can go to, I'm not sure we've got a link to it, but we can get you some information to how to sign up for those trainings that are going to be coming up. And then we've also looked at the different types of audiences. So what audiences need to know what about microgrid? So for example, someone who might be managing a microgrid project, or maybe an installation energy manager that's going to be responsible for the operations of that microgrid, they might need to know something different than, say, installation leadership or folks at headquarters. So we're starting to put some of that together as well. So slide 64. Please. So some other feedback we received was to provide more real-world examples. And so what we did was we sanitized some examples of some real-world projects that NREL has supported. So for example, NREL has been supporting Marine Corps Air Station Miramar for about the last 15 years or so, and we've kind of help them work through having no microgrid to having a functioning microgrid, and it's often held up as kind of a good example within DoD of microgrids. We've also supported 29 Palms, and they've got a really interesting system there. And so we were able to kind of sanitize those examples, much in the same way that that David did earlier in his and showed, I believe it was Fort Bliss. So sanitizing those to give some folks a feel for operationally how a microgrid, what you can expect and that sort of thing. Slide 65, please. And then a lot of times the comments we've been hearing several times is, sure, all of this information is great, but what about my microgrid? As David pointed out in his presentation, that every microgrid is different. What we like to say is, if you've seen one microgrid, you've seen one microgrid. They're all going to behave differently, have different needs, have different climate data, have different threats and hazards that they're trying to be resilient to. And so everybody is going to need, there is a decent amount of design and just considerations and even concept development that needs to go into each of those microgrids. And so what we did with that feedback was after a student attends the advanced training, they can schedule office hours with either an NREL or an ASU subject matter expert to kind of talk through their needs and whatnot. And so we would expect those folks to have in their have referenceable at any rate many of the things that David had pointed out in his slide on kind of what was sort of the minimum data that you needed to implement in their model. That was the data that he pointed out is all very common, and that's really a great place to start for your microgrid designs. Slide 66, please. So one of the things that we did, that we developed for the NAVFAC Southwest training was these microgrid scenarios developed in a real-time model. One of the platforms that NREL uses for real-time simulation is the RTDS Technologies platform, and they've got a tool in there called RSCAD. And so what we did was we used the Banshee model, kind of adapted. So the Banshee model was developed, I believe, by MIT, and it's just sort of a generic model with generic types of generation. And you can use this to kind of demonstrate different microgrid scenarios here. It's actually 3 different microgrids that you can connect and disconnect, and they're all connected to the grid. And so you can do a lot of good what if scenarios just using that model. And so what we did was we developed a few different scenarios to kind of show folks what these kind of what happens in the real world. And so looking at figure 1 here, the Banshee system single line diagram, that's sort of that was meant to represent kind of an HDMI that someone might see in a control room for a distribution system. And so you can click on the little red or the green squares to either open or close breakers and start the different generation assets and that sort of thing. And so then after running these scenarios, we were able to kind of show what it looks like, what a black start looks like using a diesel generator or diesel generators, and what a black start might look like using a lithium-ion battery. And some of the, so we were able to kind of show these graphs that we've got here on the left, and just demonstrate about what happens to the frequency, what happens to the, I think that's voltage there at the top. So we're able to demonstrate that. We also demonstrated seamless transitions, both planned and unplanned. A planned seamless transition is relatively straightforward. You need to have a lot of communication with your utility if that's something that you want to do. So say, for example, you know that a hurricane is coming and you want to disconnect from the utility in a planned fashion. You can, schedule that with your utility in many cases and make that seamless transition happen. With it being unknown to your installation, if you've got enough generation to support your installation. And then unplanned seamless transition, we were able to demonstrate that that's a lot more challenging. It sort of operates as a UPS scenario, an uninterruptible power supply scenario, and So those can be really expensive and really challenging from a controls perspective. So just in general, we don't recommend it. We recommend against trying to do an unplanned seamless transition. And so we were able to kind of describe why and kind of show why it's so challenging to do. Slide 67. And I think, Nate, I am going to turn it back over to you. Thank you.
Perfect. Thanks, Chuck. And what I really love about that example with Banshee as well is you're showing people a real circumstance in an operating control room and then providing the comparable knowledge of why something's happening or why is something not happening, particularly once you have a contingency event or an outage. You know, what's in the script to spec on page 27 may not work. And so how do you help people understand the basic principles or the underlying dynamics so that they can potentially change their approach in real time? Thank you, Chuck. And then a bit of what we do through all of these, through our demonstration projects and our training and more, is continuous engagement, feedback, and growth, particularly as the profession is advancing so rapidly. And if you take a look also at information from Pew Research, generally across any profession, not just microgrids, but engineering and other professions, anyone with a degree seeking, is that your knowledge is the half-life of it is 5 years. And so 5 years from now, half of what you learned is now outdated. And that's generally for any profession. For faster moving professions like microgrids, the half-life is even quicker than that. So we need to continuously adapt, change, and grow. We'd love for you to come to some of our forthcoming trainings. And so you see the link there at the top that you can grab and click on. And potentially one of my colleagues from the event organizers would be able to grab and paste that into something public for the attendees here today, so you can easily get it through the Zoom window. But if not, you can grab it in the slides after. We've done 6 training events. We have another 6 coming up in the next 4 months. And then a total of about 20 to 30 going out to in the next 18 months. So we have a number planned. Some are virtual, some are in person, some are in Golden in the summer, which the weather is far more pleasant there than the Sun Valley where I'm at right now. So go see Chuck, and I'll see you in the fall. And then there's also one in San Antonio for the installation innovation. But these are the ones at our facilities. But we also go to Exwick and other locations to provide training. So feel free to send us a note. And noting what David is and where he's at with NRECA, part of one of the requests out of the DoD Innovation Symposium in November, December of last year was, hey, what about bases that are in rural areas? Do they have the support that they need, large bases and small bases? And so we actually now have, out of that request, we contacted our colleagues, David, and then also Lauren at NRECA. So now we're doing a targeted training for rurally located installations and the electric cooperative managers that liaise with those installations. And so we'll do at least one of those in the fall and potentially a second one next year as well. So if you have, unique needs or things that pop up, absolutely send us a note. We'd be happy to talk to you. A little bit of conclusions, leveraging, a significant amount of hours of work and knowledge and demonstration projects to really advance the knowledge and skills of the DoD and the supporting folks, and then coupling it to the tools like David and others had mentioned on the call. Benefits are quite significant, particularly given the financial investment going to microgrids and energy resilience, making sure that it's well spent, that it actually also keeps the lights on is an outcome of having the human capacity to do the work. Acknowledgements, kindly a number of people at ASU, NREL, Chuck, sorry, copy paste there. Your name might have got deleted in there, but Chuck absolutely should be under NREL. Slipstream colleagues, and then Converge Strategy colleagues as well. Every person in terms of our small consortium has been fantastic to work with, and we connect into about another dozen organizations or commands that work with us collaboratively on training, and we're looking to formalize those relationships to solidify our offering broadly. Love to talk to you. Send us an email, give us a call. Yeah, excited about training and accelerating our impact. Rula and friends, I'll turn it back over to you.
Wonderful, thank you. We've got a number of questions that have come in for the two of you, and I'll relay the first one to you, Nate, and feel free to invite Chuck to weigh in. This question is from the Air Force Civil Engineers Center. Understanding that microgrid funding for projects and pilot projects are set for boundaries within military installations, have considerations been given to partnerships for a city or regional microgrid with local utility and governmental organizations where partners would provide funding and expertise, such as for a larger microgrid covering a larger area?
I love this question, and it's partly influenced by how the NDAA requirements are interpreted, and then also the criticality of the loads on the base. To say in brief, yes. To say a bit more detailed is that we, in any microgrid scenario or project, we look at all financing options and have those on the table for exploration, whether it be federal funding, whether it be land use lease that the federal government provides, and then a third party owns and operates the system. Is it something that connects, like the feeder provides to a military base, but then also the surrounding community or neighborhood? And is that feeder heavily loaded or not? And then that changes the relationship and dialogue with utility. And that's the importance of yes, the knowledge and skills, but then also the interactive tools that all of us are showing to allow stakeholders to work with each other under new value propositions and business models. And so if you have something specific or a series of bases you'd love us to look at, very happy to get on the phone call even for an exploratory chat. Thank you.
Great, thank you so much. This next question is from Freelancer. Have you used SKM PTW instead of ETAP for power system modeling? And which one do you recommend?
My team hasn't, but maybe Chuck, your team.
Yeah, so we actually used to have a license for SKM. I don't think we have that anymore. I know that I've been on some projects with Navy where SKM models have been developed, and you know, I think it's really good at what it's it's really good at power flow modeling and protection coordination, arc flash, that sort of thing, short circuit analysis. And so, but I think ETAP does that same thing. So I think they're comparable in that space, but I'm not super familiar with the functionality of ETAP over SKM.
Great, thank you both. This next question is from the National Institutes of Health, and the question is, what software do you use to design your interactive games?
Oh,
Nate?
I'm gonna have to take that offline. Much like Dave, David's a software guy, but didn't have the military background. I have the project expertise, but not the software engineering. I'll have to run that down. Thank you.
That's fair. This next question is from GE Vernova. Is the Banshee network model available publicly?
I believe so. I think I'll have to take that one offline. Nate, you might have some information on that one.
Sounds good. How do you change your approach to training when there is a specific project or effort to support? Nate?
Yeah, when there's a specific project or effort to support, what we've done is provide or a particular stakeholder group, provide the generalized training, and then we swap out the case studies or examples, particularly utilizing CUI data in certain settings where we couldn't in others, and then utilize that as a guide or illustrations to drive the specific needs and questions for that project. We also go through kind of like a design charrette to storyboard what the project needs are with a variety of stakeholders. And then since we have so much training content, we then can adapt often on real time about which like skills or tools or examples that we pull together to deliver and meet that need.
Thank you. This next question is from SNC Electric Co. Does your training include any focus on electrical analytical studies, short circuit coordination, and dynamics?
Absolutely, it does. So there's three-phased, unbalanced, short circuit, arc flash. We've done some protection and coordination, but usually don't get enough demand signal to have set up independent training on that. Yeah, and then of course distribution network design and then balance of system. Chuck, you might have had your team lean into some of the things that we haven't. Please let us know.
Yeah, we haven't gone deeply in that type of training on our side that I'm aware of.
Thank you both. This next question is from Spectrum Solutions. Do you employ artificial intelligence techniques or tools for decision-making within your architecture?
That's a really great question. And I would say that we as a sector are on the fringes of understanding exactly how to apply AI well instead of just apply it and have really good marketing. One thing is that we are applying it for just starting to, but it's not something that's usable yet, is coincident threats. And so if there's a natural disaster, cyber attack, or physical attack, yeah, we can identify and analyze and create a number of threat vectors that a person can be trained for, but there's also things that we just completely don't know about. So the unknown unknowns. And that is where we're starting to use AI to create scenarios and threats, physical, natural, cyber, or otherwise, that then influence the type of training scenarios that we have. When it comes to design, I haven't found as many utilizations directly as the machine learning and other types of computational techniques that we've done. But maybe Chuck and the NREL team, you've found more immediate uses for AI than we have.
Yeah, one project that I'm familiar with is another ESTCP project that NREL is working on. We are looking at using machine learning to do load shedding. So kind of based on weather and load and, kind of learning about what load might be doing on a particular day, using that to do automated load shedding. And that's mostly around HVAC set points. So in the summertime, think about increasing your set point. So going from 72 to 76, that's going to have your HVAC systems working a little bit less hard and then reducing your load. And so that's one project that I'm familiar with, but I think there are a few more going on at NREL that I'm not aware of. Thank you.
And one thing, if I could just kindly share back, I got back from my software person, the program that we use to develop most of our games is Unity.
Thank you so much. Just a little note, David Finney has asked that we relate to all of you that microgridup.org. His webmaster has just made the fix to the link, so it should work. Thank you for that, David. All right, one last question for Nate and Chuck before we go ahead and wrap up. How is your approach to workforce development different from university educational preparation?
This is phenomenal. Yeah, so academic preparation leading to a degree is generally focused on knowledge and not as much on the application, whereas our training for the working professional is largely focused on the skills and the application. that's supported by the fundamental knowledge. And so it's far more on skills and application, which is what we need in our profession. Is we don't need a textbook. We need, you know, a reference guides and the tools for direct application for the unique need we have. And then there's, of course, the hands-on component, the simulation component, because the application of the knowledge is what we focus on. Maybe Chuck, if you want to add any more, please do.
Yeah, most of our training, I think up to here was, you know, it's been really great working with Arizona State. They've got a really deep and broad content for microgrid training. Typically what NREL has been doing is kind of overviews for different agencies. We also did some training for FEMP, DOE's Federal Energy Management Program. We have a series there. So it's mostly kind of the knowledge piece. So it's been great working with ASU where they can bring this, you know, bring a little bit more of a codified approach to training and get into, you know, the training that's meant for a working professional. Thanks.
Great. Great. Thank you both. Actually, thank you to all our three speakers for a wonderful webinar. We're going to go ahead and wrap up. I'd like to remind you that our next webinar is in 2 weeks. It'll build up on today's topic of research to increase energy resilience through microgrids. The June 27 webinar will feature 2 speakers, Dr. Jeff Marquesi from NREL and Mr. Halliwell from the Electrical Power Research Institute. Please visit the CERTUP and ESCCP webinar webpage to register for this and other webinars through the end of 2024. And before we conclude, as Tim mentioned, I'd like to remind you that the audio and a copy of the presentation of today's session will be archived on the webinar webpage in case you would like to refer to them in the future. We would appreciate it at this point if you can please take a moment to complete the survey that will pop up on your screen. This concludes today's webcast. Thank you for joining us.